Thank you very much, Cosimo. Great to be with you again, everyone. Hope you're going to have a good time in the next few minutes. So for those of you that haven't joined before, because of those of you that have, this is probably a bit boring by now. This is where I am in the UK. So down on the bottom right-hand side, the southeast there, I'm right near the coast in a little place called Felixstowe. Well, it's not that little. Actually, it's the biggest container port in the UK. At the other end of town, and talking today about 5G. But before we get going, I think Cosimo's probably said most of this. You can also get to the previous webinars I've done in the last couple of months by going directly to nevion.com/YouTube and pick them up there. We're still trying to decide when we do the next CTO webinar, because that's just because of vacation, although I'm not sure anyone's going anywhere. So watch this space for when we actually do stuff next. But do draw your attention to the one tomorrow, the joint one about Sony and Nevion working together. You can still register for that, so search it out on the Nevion website. And finally, if you haven't had a chance in this lockdown time to actually have a catch up with our solution architects and our account and sales teams, then please do that. If you have any problems with that, then I would be very happy to put you in touch with the right people within our organization. Hopefully that makes sense. Right. One more quick slide before I actually get into the meat of the presentation for today. And I always have to share a little bit of personal updates in this thing. So the very exciting news is our second granddaughter has been born in the last week. So last Friday morning she was born. And just to make it slightly relevant, I did this with Esther, our previous granddaughter. So I reckon about this time this morning, here she's about 21 million frames in since her epoch, whereas I'm actually 2.7 billion frames in, and that's all, of course, at 50 frames per second. So there you go. Anyway, there's a little technical reference there. So for those of you that aren't that familiar with Nevion, one of our passions is being involved in standardization. So everything that we do within what we develop with our aspiration is to do with making things open and accessible and interoperable. And we're involved in everything from the very definition of standards work right through to implementing it and obviously promoting it in the marketplace. So that's really the Nevion DNA. And just a final slide to just make sure you're aware of the main portfolio solutions that we have within the Nevion offering. Several of which you'll see as being relevant in what I'm talking about today. Video UiPath is our overall SDN orchestration and control system, which does so much more than just control things. It's all about management, both time domain and resource management, everything from network bandwidth to actual end devices, to virtual resources, to physical resources, and actually provisioning everything. So that's Video UiPath, an incredibly important part of our ecosystem, and we've been working very hard on scaling that as facilities and opportunities have been just getting bigger and bigger and bigger in recent years. And in Virtuosa, our software-defined media node, this is what I call a generic bespoke. It's a generic chassis with bespoke accelerator, and we can run a whole load of different software implementations on that to fulfill many different functions within the broadcasting chain. And again, some of those will be relevant as I unpack a little bit of stuff moving forward. The badges at the bottom are all part of the proving that we are really part of the consensus of the industry in moving in standardization and proving interoperability. We're very proud to have those badges, which we've been awarded over the last 3 years by independent testing across the industry of our conformance to standards. And last but not least on this slide, the baseband to IP to virtualization book is available. It's kind of our, if you like, broadcast Bible. We've been writing it and updating it roughly twice a year for the last 5 years. So we try and keep it completely up to date. Myself and Olivier, our VP of Marketing, have been working on doing some updates in recent weeks. So there's a new version coming out, but we do have that version available. It's available in paper form, but that's a tad tricky to get hold of at the moment. So we do also have a PDF version of it, which we can let you have. So if you would like a copy of that, do reach out to myself or Cosimo or anybody else in the Nevion team that you know. Right, okay, so on to the topic for today. We're talking about 5G and specifically, obviously, its application to the broadcast production space. But there's quite a lot of context and background I want to give you, just so you see how what we want to do with 5G as broadcasters fits into the whole world moving towards this next generation of mobile technology. So first of all, just to say that, obviously 5G rollout is happening. This is, I think, a pretty up-to-date slide. I got it off the Ookla site only a couple of days ago. So it's just showing you that there is a large number of 5G deployments happening already. And the vendors on the left-hand side are reference vendors that have actually got 5G capable handsets that are being sold as well at the moment. So there's a lot of people have got devices, and there's a lot of places in the world are actually already doing 5G, but with some caution, and we're going to unpack this as we go. Specifically, what they're doing is, at the moment, all of the 5G you see and consume, if you're lucky enough to have a handset and coverage where you are, is what we call the enhanced mobile broadband, which is kind of what I would describe as more of the same of what you get with 4G. So it's basically just more data, more bandwidth of the same stuff really at the moment. Although we're going to talk about obviously the other potentials in the 5G toolkit as we move forward. So just thinking about some of the elements of broadcast and where 5G is going to be of value. The two main focuses really, I guess, within both the standards work that we're watching in 5G, and also the aspirations of people is, one is consumption, so actually the distribution of broadcast content, and the other one, which we're going to focus most of the time on and look at some of the testing we've been doing, is on the production side. But those two are very, very key and different applications for 5G technology with relation to broadcast. Just looking at the broadcast production space, and again, this is a slide, if you've seen any of my presentations in recent times, I love this slide because from a Nevion perspective, this really encapsulates everything that we're doing within the broadcast community. So we've got within this diagram these four kind of tenets of stuff. We've got the facilities and the light green squares there, rounded squares, which is everything about an IP production campus. We've got the OB van, which typically has got similar stuff but less of it in a more compact form. We've got remote production, which is the interconnection of vans, facilities over long haul connectivity. And then we've got distributed production, which is where, as I've been saying in recent weeks, we really leverage the true benefit of IP, because this is where we actually start to be able to share not only physical resources, we'll be able to share people resources, we were able to share real estate like studio floors and galleries, etc. And what we're going to be looking at in 5G, and I think the anticipation and hope of 5G from a broadcast perspective, is that it's going to actually, within this diagram, enable us to do a lot of things within this space in a more flexible and agile manner moving forwards. So just bear that in mind as we unpack at this. Now, very excitedly, some of you in the press may have seen yesterday, we actually released a press release on a Nevion Commission broadcast industry survey that we have done in the last few weeks. And this was really to gauge what broadcasters are actually saying about their readiness for embracing 5G, and also how much they've actually already investigated it. So I was kind of quite surprised to see that it has, this slide actually says however only, but I'm quite surprised that almost half of broadcasters have already been working with 5G technology, because despite all the hype, it is still very much in its infancy, especially when we look at broadcast related features. But this is an interesting slide. You can actually, if you go to the Nevion website, to the press release area, you can see this is one of the most recent things that we've published. So, and there's quite a few more bits available in the study for you to unpack on there as well. But this just is a snapshot we've taken of the industry in recent weeks to actually gauge where they're. So, and really, I guess what we're saying is that there is an expectation there within a couple of years that 5G stuff will be available to use to complement and enhance what broadcasters do. So we'll unpack whether that's going to be really a reality within that time frame as we move forward here. Just so you're aware, Nevion has actually been investing a fair bit of time and resources in a variety of projects, formal trial projects, mainly part of the EU Horizon 2020 set of projects. We are actually heading up one project, which is called Virtuosa. And that's focusing on looking at remote production futures and the complementary nature of how 5G can contribute to that. We're also one of the stakeholders in the 5G Vinnie, which is a project that is being done by a lot of service providers, mainly across Europe. And I'll talk a bit about all of these a bit later. And there's another emerging, in its infancy, project called 5G Records, which is all about media production. And that's in its infancy, but that's something we're also an interested party in. So what I think we need to do before we get into the broadcast specifics is unpack what 5G is. And I think 5G means different things to different people. To some people, it means just the fact they can do more stuff with their mobile phone. But very much, as I see 5G, it's a toolkit. It's a toolkit of technologies, some of which are available now and some of which absolutely are not yet available. But there are two key applications of this toolkit. One is in the provision of next generation telecommunication services, and the other application is as a radio technology toolkit, which is not necessarily associated with mobile telephony service provider services. So I think we'll look a little bit at both of those as we move forwards. So what is the promise of 5G? So I've already alluded to some of these things. From a data perspective, the promise is there's masses more of data. From a latency perspective, there's a promise that it's much lower latency, and there is a promise also that it's going to be optimized for other capabilities as well. And if I move on onto this diagram, I think this kind of summarizes, if you like, the big world view of 5G. So, I haven't forgotten the broadcast piece, but this is, if you like, the mass user global vision for 5G and the majority of the stuff it's going to be doing. So on the left, I've been talking about already, which is the enhanced mobile broadband. That's kind of just faster data, more data available to you wherever you are. On whatever you're consuming or using that data for. Then in the middle, the Internet of Things, and the interesting thing about the Internet of Things, if you're not kind of familiar with the kind of requirements there, is that the thing is we're going to have many devices. So we're going to have a lot of devices, but most IoT things only need tiny bits of bandwidth. So there is a scale there. So it's not getting lots of data to a relatively small number of devices. It's getting small amounts of data to and from a very almost unimaginable large number of devices moving forward. And if you think the models, the way you actually do data exchange needs to be significantly different to do that. And then finally, possibly the most scary bit of it is the is the high availability and ultra low latency stuff, which, you know, one of the big cited take-ups there is automated driving, because cars that are in close proximity need to be able to communicate with each other, and you do need them to be able to do that fast, and you do need them to be able to do that reliably. And there's obviously other things associated like that with edge compute, which can actually make those things work well. So those are the three key headlines. This slide kind of unpacks it a little bit more. So obviously already in the EMB, enhanced mobile broadband at the top there, you're seeing a broadcast application for UHD video. Other applications for the low latency, high reliability stuff in the middle, and then all of those other potential applications for the IoT. So those are, broadcast aside, the key focuses of the mobile industry moving forwards for this. And yeah, so the kind of numbers that I've seen touted here are the high bit rates on the top left, you know, being able to sustain 1 gigabit per second as a consumption. That's downstream, and we'll come back to the asymmetry in a minute. The low latency and high availability, and then the concept of, obviously, as well as IoT needing only small amounts of data, it also needs to be very, very power efficient. So it needs to be able to actually send and receive data in a manner that's very power efficient. So we have very long battery life as well. Okay, so those are the big consumers of 5G. If we now look at my perception from, you know, how things are going, the way the industry is prioritizing the 5G rollout and stuff that needs to happen. So you've got the enhanced mobile broadband, the more of 4G type stuff, largely speaking, at the top there. We've then got the ultra low latency, high availability and the Internet of Things, and then at the bottom there, just tucked in, and as you can see, my presumption is that it's actually behind the others, is what I call custom quality of service requirements. And I think we as the broadcast industry aren't unique in wanting some of those capabilities, but certainly it's not mainstream, and you know, therefore is relatively far down the pecking order in terms of when some of those elements will come up. Now, if some of the stuff we can do within broadcast actually is just EMBB related, so if it's file transfer, getting those video files back quickly in a non-real-time basis, but fast from an event or something, then there is lots of benefits even now with just the EMBB. But where we actually aspire to get to for broadcast at the bottom is probably a bit further out. And then there is just a massive caveat even on that, which I just want to put in at the moment, because if you talk to, I think, many service providers, you'll see that there are some challenges here. You know, as we know and love, and the reason a fair number of us have got a job is that live media broadcast production is special. We're all very special, but that does lead to the question of viability, commercial viability from a service provider perspective. I've personally, you know, worked on other opportunities with other technologies where, you know, the big market for them hasn't been seen because they've been broadcast specific, and therefore they haven't necessarily come to fruition, or they've come to fruition much later than expected. So I'm just kind of putting that up there because I think that is a kind of a risk factor with the expectation of the broadcast centric features within 5G. So just a few more bits. I'm going to spend the next 2 or 3 slides pointing you to the organizations that are really running 5G stuff and standardization, just so you can go and look things up. The first one is the Third Generation Partnership Project. This is an initiative that was founded 22 years ago, and I think I was looking at my phone thinking when I first started texting, and that was probably around 2000. So the 3GPP predates even me sending text messages, I think. So been around for a long time, and this obviously isn't broadcast centric. This is the coming together of all the global interested telecommunications partners, really, to make and evolve all of the different mobile generations work, and obviously we'll have a look about where that's got to and unpack that in a little bit. So that's kind of the global industry as is. If we then look at public service media and the influence that broadcasters are making on the requirements within 3GPP. This is a slide I borrowed from, I can't even remember where I borrowed it from, so apologies to whoever I borrowed it from. But this is encouraging because certainly from a European perspective, here on this slide, you'll be very encouraged to see that there's actually a lot of people involved, a lot of the senior people in Europe involved in broadcast that have been influencing the 3GPP standardization work and the releases and the specifications that are contained therein. So there's been some influence, and I think probably this was release 14, which is going back 2 or 3 years, is the first release where we started to see some significant broadcast related features being put into the toolkit, if you like, of the evolution of the 5G specifications. Some of these you'll obviously see are very relevant, and 1 or 2 of these I'm going to talk about a little bit more. And then this next slide is not for you to actually even try and read or consume, but this just shows you that there is a massive amount happening, within the 3GPP in terms of the specifications and the releases. You can see the roadmap that they've got there for the next 5 years. You can get all of this from their website. There's a lot of stuff happening, and again, just to put it into perspective, only a tiny bit of this is broadcast related. So we're influencing here as broadcasters, a massive piece of global initiative. Just want to give a shout out to specifically to Ian for some very useful input that I've used as part of this presentation. He's in BBC R&D, and he actually chairs 5G CP, the content production group in the EBU. Again, it's well worth checking out the work they're doing, because that's very much broadcast related initiatives within the European environment, and the BBC themselves have got some useful references and resources on their site, so I'd encourage you to check those out as well. Now, coming back to the potential for broadcast, just to remind you, there is the broadcast consumption and there's broadcast production. So just a couple more slides on the consumption piece before we move into production. So going back to the EBU, they've done a very useful paper, which I think was only released last month, TR054, on the use of 5G for the distribution of media, basically. And this is one diagram from there that talks about the related 3GPP releases, the stuff that relates to broadcast within that. But just want to say, in media distribution terms, thinking about broadcast distribution, there are 2 key differences here. There is the linear services, which is all about the real-time flows which we're actually sending. That's when the broadcast specialness comes in, because we need to be able to consume that. With linear stuff, we need to be able to broadcast to multiple users simultaneously in an efficient manner, and it's a real-time flow. So we've got all those nuances of actually how we make sure real-time flows work with integrity. The non-linear services is very much about the consumption, almost file-based consumption. So that falls back much more into the EMBB type stuff, where you actually it's pulling data to consume. So more of the on-demand stuff. And obviously, there are some broadcasters that are using a hybrid of those. So linear programming, but with lots of augmented programming, and that you can pull on demand. And again, just to go back to that very first slide on what is 5G and that toolkit, there is some specific work on 5G broadcasting, how you actually use the 5G technology for efficient broadcasting. And then there's the other piece of work, which is how we use 5G mobile broadband and the tools for broadcasting within that. And those are two separate and complementary things, uses of the technology. So I think I've probably covered this sufficiently in the slide I just talked about. But we have live and non-live, and the very specific difference is live production. When we're doing live production, it's all about the real-time behavior, and that's the stuff that we've been focusing on in our testing, which I'm going to talk about shortly. The broadcast production, where people are actually effectively shooting stuff, recording stuff, and then just uploading it, that's actually a relatively straightforward behavior, because you haven't got the nuances of timing, of latency, and all of the other things which I'm going to talk about later. So live is the bit in broadcast production I'm going to focus on. This is a little diagram. This is one I made, which is why it looks nowhere near as sophisticated as some of the others you've been looking at. But I think this attempts to encapsulate, this is kind of what we put together for our trial. But the reason we put together these elements within our trials is that these are the key areas that are perceived as being important as we look at live production. So what you'll see is the 5G infrastructure in the middle, where it's very specifically peering into that cloud, both at a data plane layer and a control plane layer via API, and we'll talk about those elements of that. And then basically we've got lots of broadcast resources that are connecting it directly into that 5G infrastructure. Typically, obviously, capture devices such as cameras and microphones, but similarly things like portable gallery. Someone I know has got this big passion about being able to actually do full production, gallery production from sitting drinking a coffee in Starbucks on a decent laptop or iPad. And I dream of being able to go to Starbucks and do that kind of thing, but one day we'll be allowed to do that again. And at that point, then yeah, this could become a reality. So those are the kind of if you like, that's kind of a schematic of the kind of things we've been looking at and investigating. And then now let's just unpack some of the requirements that we have for live broadcast. So first of all, the key thing, I guess, that we're trying to enable specifically with this mobile technology is the flexibility and freedom. Coverage is obviously vital, and again, because it's in its infancy, that's potentially a challenge at the moment, but as things roll out, hopefully we will get more and more coverage. But obviously you need the appropriate amount of coverage where you need. We're going to unpack some of these others in a minute, but you need guaranteed bandwidth. If you're going to actually have deterministic transport, you need to know you've got the bandwidth to send your stream. And that's possibly the biggest challenge of all of these that are bullet pointed on here. Latency is important, especially if you think about the various control loops, be that in an interactive interview scenario, in a contribution environment, but also just in terms of the sheer way you actually adopt the flows and pull them back into the production gallery remotely. Dynamic control of the data plane. Again, this is probably moving a fair bit down the road of where we're going with 5G, but the idea that we can actually create end-to-end connectivity on demand, which includes 5G connectivity as part of that. Security is obviously vital, and authentication is key as part of this. And then again, the inverse asymmetric connectivity. If you think about typically, as a mobile broadband consumer, you're typically consuming a large amount of bandwidth, very much like your DSL line at home, a large amount of bandwidth downstream, and typically you don't take much upstream. If we're actually thinking about very distributed or remote production using mobile technology, then all of our devices, the cameras and the microphones, are basically wanting the big bandwidth the other way. It's the upstream that's really important. And again, I'll talk about it later, but we've actually seen so far that that asymmetry that exists, certainly in the trialing we've done, is not overly helpful at the moment. Okay, so another just overview of what we typically have as what we typically enjoy as broadcasters, professional broadcasters. So high availability, that's a must. We must keep the show on air. We typically have got very used to, in the last almost 10 years now, having spatial diversity protection. So we actually have dual redundancy with completely seamless merge technology to allow us to actually benefit from that. Typically, we have constant bitrate data flows, which is atypical to the use of 5G for the EMBB stuff. Typically, we enjoy incredibly low packet loss in the connectivity we have on private wire. We have introduced in broadcast various technologies, error correction and packet retransmission technologies to allow us to overcome those few packets that do get lost. We've obviously got quite tight timing requirements, and typically we've been using very low latency compression to actually where we've had to use compression. Now, there's a toolkit which I've talked about, I think, pretty well in every seminar I've done recently. This is a toolkit of SMPTE 2110. I just wanted to highlight, I'm not going to spend any time really on this at all, just to say that this is important because what we're thinking about doing in production is reconciling our mobile, our 5G enabled contributions into this ecosystem. So some of the elements of 2110 need to be adhered to, or ideally adhered to make it a fully seamless integration. And one of those big bits, coming on to Andrea's favorite topic here, is timing. Timing is incredibly important, and we've got a couple of key requirements for timing in our use for production, mobile production with 5G. One is synchronizing the camera. So typically in a studio, you're probably aware, we have what we used to call in the good old days Genlock, where we actually provide a reference signal to the camera so it knows where it starts its video frame, how it actually aligns the data, and so it's frequency and phase locked to the system timing of the facility. We have in recent times moved to doing that over PTP, which is a 1588 IEEE standard, which we've been applying to media using a SMPTE standard called 2059. And that's defined, if you think back to my epoch I was talking about of my granddaughter and myself earlier, it defines the timing of every video frame relative to the starting epoch, which happens to be 1970, which sadly happens to be after I was born. But it times everything back to that. So you can actually, using this very high precision timing information that PTP gives us, we can actually work out where our video frame needs to start. So it's like a digital big number, which allows us to do the maths on where we actually start video frames, and indeed what video frame we are actually on. So synchronizing the camera is one important bit. Another thing we need to do within this world is also to actually add timing information to the packets that we generate in the microphones or in the cameras. So they need to be aware of time to be able to generate that. Now, the good thing is within 5G systems, there's a lot known about time. So as you'll see from this Ericsson diagram here that I've got on here, there is actually quite a lot of time sync requirements and timing accuracy requirements, which are pretty tight. They come tight enough for what we need in the broadcast industry to use. So timing information is available within the 5G system. My understanding is that we've still got some way to go to actually getting to the point where we actually can have proven that we can extract that time and have it available in a manner that we need for consuming within our devices. Obviously, that timing information is typically got from GPS or other GNSS systems, but also for resilience via other techniques as well nowadays. Now, deterministic data transfer, I think I alluded to it a few slides ago. I've put that ISDN picture on at the bottom there because the good old days, this was pretty low bandwidth stuff, but the thing about ISDN was you knew you had your 64 kilobits per second or your 128 kilobits per second worth of data. It was guaranteed because you were in a TDM multiplex, you were being given that data space, that data capacity, and you were guaranteed it. And even in times of some of these COVID at-home presentations, it's interesting to see that even now, when ISDN is kind of being phased out, the broadcasters that have got the most reliable, lowest latency deterministic performance from when they're contributing from home are the people that have still got ISDN rather than the people that are doing it on their broadband connections. Because the big challenge with both DSL technology to the home, which is how most of us consume most of our data, and also the 4G and 5G technologies, is everything about it at the moment, however you consume it, 4G or 5G or on DSL, certainly in the UK, is all best efforts. It's all contended. There is no guarantee that you're going to get the data you want. So one of the real gold offerings that is a hope within 5G technology is that of slicing. And the concept of slicing means that there is the potential within the toolkit, or there will be when the standards are all finished, to actually have a dedicated functional layer that, on a shared infrastructure that actually gives you the bandwidth that you need. Now, just to say, at the moment with EMBB, everything that's 5G that's rolling out at the moment, that doesn't exist. We're still in a best efforts environment, but that's the potential of where we're hoping we're going to get. And we're looking forward to doing some further testing of network slicing during this year as part of some of the trials that we're involved in. But this is the holy grail, if you like, of 5G for anyone that needs deterministic bandwidth. It's that promise that we're actually going to be able to have the potential to have that guaranteed bandwidth available to us. Now, I just want to rewind to that viability slide back at the earlier, because that's only going to become an offering from service providers on infrastructure if it's commercially viable. So we have to hope that broadcasters and other people that want to consume deterministic bandwidth on 5G actually club together to do that. Just talking a bit about the control plane very briefly. So one of the things that video iPath in Nevion land is being used for on lots of distributed production environments is actually managing not only all of the bandwidth and devices within facilities, but managing the bandwidth that's between facilities, so that wide area interconnect. And the work we're looking at hoping to do, again, we haven't started these bit of testing yet, is actually the 5G control APIs being able to talk to the 5G network to actually instantiate dynamically that network slice, that QoS, that bandwidth that we need. So we can actually build a deterministic end-to-end connectivity that we need to fulfill what's required for the production. Compression, it goes without saying that whilst 5G offers high bandwidths, much more than we've previously enjoyed, it doesn't offer high enough bandwidth for us to actually run stuff uncompressed. I mean, you saw in that very first slide about what the aspiration of 5G is in terms of bandwidth, and a sustained rate of 1 gigabit per second was talked about. That's kind of unrealistic in terms of consumption, especially if we're looking to doing typically a pop-up production where we turn up with 8 cameras or so, all of which are 5G enabled and all of which want to backhaul and uplink significant, pristine pictures. So we've obviously been using compression within the broadcast industry for a long time, 30 plus years. And in fact, I guess if you'd call interlace early compression, we've been doing it for 80 years. But this toolkit here, we are using in broadcast already. Typically now JPEG XS is becoming, this year, the kind of de facto mezzanine compression. It gives you roughly a 10-to-1 compression which may be take us back down to a usable bit rate for some of this pristine 5G production. Having said that, most of the people are actually doing anything like camera packs or looking at those kind of things, typically are currently using what I call temporal compression, aggressive compression, which gives us maybe up to even 100-to-1 compression ratios, and that's using HEVC or H.264 toolkit. So compression is a very much big part of it. The challenge there is obviously it's a trade-off between bandwidth consumption and, as you're all aware, latency. So how long it takes. The good thing about JPEG XS, this mezzanine compression, which we as Nevion are adopting and rolling out in significant volume this year, is that it's very low compression. It's sub-millisecond. So in the scheme of things, once you're going long haul, it's irrelevant. It's negligible compared with the transit time, the propagation time. Obviously, if you're doing temporal compression, there's lots of bits of the toolkit to actually shim bits off and make it as efficient as possible. But you are actually going to be adding some relatively significant time. Although if we look at some of the tricks that have been adopted by radio cameras, COFDM radio cameras, the types of stripe compression tools they've been using have actually managed to get even temporal compression down pretty efficiently. Won't dwell on this, but just to say some of the IP delineation for the data flows that I've been talking about in previous webinars also applies to here as we talk about those peering points and the handoff between the native 5G infrastructure and the broadcast infrastructure. So this secure gatewaying from our broadcast production center to the outside world where we're peering in 5G infrastructure like we're peering in other OTT internet contributed stuff is very important. I'm not going to unpack that. You can listen to that on previous webinars. Just a few minutes about trials. So the 5G Vinnie project, which is one of these Horizon 2020 EU projects, very excitedly has got its two biggest test points in Oslo, which is where our large development center in Nevion is based, and also at Adastral Park in the UK, which is where our other development center is, and that's where I'm based when I actually am in the office nowadays. And this is an aerial picture of Adastral Park. So this is the site where these and there's already a significant amount of 5G test infrastructure here, which we've already been working with, predominantly Samsung equipment on this site, although there's different equipment vendors in different sites, and both millimeter wave and lower wave bands test infrastructure, which we've been starting to work with already. Again, don't expect you to look at this slide, but this is just the official Vinnie timeline of the work that they're doing in terms of looking at that, and the test project that we're involved in basically means we're going to be doing testing throughout this year and throughout next year as well. Moving on to the Virtuosa project, this is the Nevion-led one. We've been working with 3 key partners on this who are listed there, and we've been looking at basically building up IP production infrastructure and then looking at how 5G complements that and how 5G actually allows us to actually benefit there. So trying out some of those bits. Again, I'm going to come to testing methodologies and results very shortly. Also to say, if you look in the public press, if you look on Sony's public website, you can see as an example, they've actually done during last year 2 key demos of and tests of 5G broadcast for live production. So people are in the world are already, this is one in the US and one in Europe, people in the world are already doing some trialing, albeit with some of the restrictions of that I've already cited about what the infrastructure currently provides for. So coming back to this production environment, I just want to focus for as we come into land on some of the testing we've done and what we've been looking at, and then a little bit about how we've been doing this. So testing the data and control planes. This is kind of the key thing we've been focusing on, and I think I alluded to some elements of this earlier on in the presentation in terms of the stuff we've been looking at. But round trip timing, key importance. Obviously, packet loss and how that looks is incredibly important. Data timing variation, what we would call packets delay variation in a pure IP world. That's been an interesting one, and probably without saying too much, I think that's one area that I think we're still focusing on, looking at the performance that we're seeing from the systems. This bandwidth asymmetry is also a key interest to us. Obviously, all of those EMBB consumers are wanting high bandwidth down, low bandwidth up. We have the inverse requirement, and getting the infrastructure to allow us to do that kind of asymmetric uplink rather than downlink is a key thing. I've already been through the timing requirements and how we're looking at the options there. I think there are being some bits baked into the specifications, the releases moving forward, that actually will allow us to do that. We've then got some more wacky stuff that we've been looking at. I talked about earlier some of the RTP spatial diversity stuff that we've been enjoying in typical broadcasts. We want to explore how we actually can do some of that in a 5G world as well, to give us those 5 nines performance, and also how, if we're in a moving environment, not so much in a static environment, how cell handover performance actually impacts that. So those are the kind of tests we're doing as well. And then also that API interfacing for the control plane to look at how we can actually do some of this dynamic building of the QoS enabled performance. So hopefully that's given you a flavor of where we're at, where we've got to, both in distribution, but very specifically in what work we've been doing on mobile production. We're hoping to publish some results in this autumn of where we've got to, and very much, I talked at the beginning about the technology toolkit for radio versus the mobile broadband service. Very much, we're trying to analyze it from the service perspective about what we'll be able to achieve over the service. I know the likes of the work, several bits of the work the BBC and EBU are doing is very much also on what the 5G technology toolkit allows us to do with broadcast, more from the distribution perspective. So those are equally important for broadcast. Timescales, I think, is an interesting one. I think the fact that the industry has rolled out 5G already, it means that I think there's almost an expectation that we'll be able to do what we need in the broadcast world as is now. Obviously, that's patently not the case for the bells and whistles that we need to make that broadcast reliable. Now, I know broadcasters have been using bonded LTE for several years now to do what I would call best efforts broadcasting, which works fairly well most of the time. The challenge being, obviously, typically the kind of events that you want to cover for broadcast are the kind of events where you have lots of people who are all trying to consume bandwidth as well. So in terms of the contention models and the lack of QoS, that doesn't play into the classic stuff. Although, talking back to the challenging COVID-19 times we've got at the moment, it's interesting to see how many risks broadcasters are taking with best efforts infrastructure for DSL to home to allow people to do, live home contributions. And actually, because the sheer bandwidths available have been upscaled, it does work pretty well a fair bit of the time. But if you listen to much radio or watch much television, you've only got to watch for a little while to see the fact that with best efforts, you do get strung up in terms of quality performance quite frequently in terms of things not working. So we really need the timescales on those QoS enabling elements to really come to fruition. But I think we're talking about the order of, a good couple of years. So going back to that survey we did, I think for broadcasters to have everything they need in a timely manner within the 1 to 2 year time frame is probably going to be challenging. But there is huge potential. So, 5G, I'm not trying to be a downer here, 5G has massive potential. And if we can elevate the specifics that we need for broadcast and get them actually realized, not only in the technology toolkit, but also in commercial offerings, then I think there is an immense potential for an unbelievable new level of freedom in how we actually do production in broadcast. The idea of just popping up, as I said earlier, with maybe 8 cameras, stepping out a van, getting them out their flight cases, and 30 seconds later, you've actually got a distributed multi-camera production that's being run from a remote gallery. That kind of stuff is incredibly exciting moving forward. So I would say watch this space. So hopefully that's been of some use to you. I'm guessing some of you will probably have known some of that already, but hopefully some tidbits have been of use within that, and it's given you some good background also on what we're doing. As usual, if you ever get to see me in person again, when we can travel, then I would love to have a nice cup of tea with you, make you a nice cup of tea. If you want to reach out to me on my mobile or on my email, those are my details. We're coming up to the end of our time together. I'll go back to Cosmo to see if there's any specific questions that we could do just within the next couple of minutes before we close. Thank you for staying with us. Those that have been here till the bitter end, been great to be with you again, and look forward to seeing you again in a few weeks when we do our next webinar. Thank you very much. Back to you, Cosmo.
Thank you, Andy. I think it's been really, really wonderful. It's a very interesting topic. Everyone agrees on that. We open for questions and very much like to get your feedback about that. So Paul Maroney is asking, 5G API, will someone, a public person, be able to use it to control a public 5G network?
Okay, so I mean, this is stuff that's very embryonic at the moment. Certainly from the testing that we've been doing, my expectation is that would be baked into a private control coupling. So it will be a privately peered control system that will be there. I'm sure there will be an abstraction to APIs at some point should operators want to make that available commercially to book that. I guess the utopian view there from a broadcast perspective, or for anyone that needs a QoS enabled environment, is that people will be able to actually go onto some UI on a website, log in, and actually book a slot where they actually have a guaranteed bandwidth. I think from a technology perspective, I'm convinced that is a possibility that the toolkit will allow us in 2 to 3 years' time or whatever it is. I think from the reality of a commercial offering where that's actually being provided by service providers, the jury's out on that. Going back to DSL, the example I would give you on DSL is, what I would really like to have happening is that option to be available DSL, where you can actually, as a home user, be that professional or non-professional home user, you could go in and say, I want you to guarantee me, 3 megabits per second uplink, for these hours tomorrow. So that hasn't even happened on DSL, even though that's something I've been campaigning with for I think about 12 years, certainly in the UK, with service providers. For consumption, specifically for broadcast consumption. So whether we get to that point as being available in within 5G, the jury's out. I hope so, but again, I think it's down to kind of the commercial viability of that.
Thank you, Andy. While you were explaining the questions, I just pulled up an existing website. Actually, you were talking about different projects and specifically the Nevion-led consortium for 5G broadcast remote production. So it's actually dedicated website. You can access typing on your browser. What you see there is 5g-virtuosa.eu. So in case you need to explore a bit more about what Nevion has been doing in this area, as Andy has already explained to you. Is there any questions?
We've got 1 minute left.
To go. Yes. So while waiting for a question, I just want to remind you, as at the beginning of the webinar, that the recording of this presentation will be posted on Nevion public area, and also, as Andy told you at the beginning of the webinar, also on Nevion YouTube dedicated website. Of course, you feel free to ask Andy any question offline if you have any.
Yeah, do email me. I'm very happy to take emails. And if you want to actually, if you're a partner that wants to do some collaboration in some of the testing or anything like that, we're very up for working with people to actually make this come to fruition and to help the likes of the BBC and the EBU and other organisations that are trying to actually bring together the broadcasters, because it's as we join together as broadcast users, we can hopefully influence the big giant that is 5G to actually get some of these USPs that we need, to make broadcast really fly on it.
Okay, and I don't see any other questions. I'll leave the floor to you to say bye-bye to everyone.
Yeah, thank you again for your time. Do check out the other webinars if you haven't already on the YouTube site, etc., and on the Nevion website. And look forward to seeing you in a few weeks' time for our next one. Watch this space. Cosmo will be sending out information when we've actually decided exactly what date we're going to be running that on. So
absolutely,
take care, stay safe, and hope to see you again soon.
Thank you. Have a good day. Bye.